Now that we have analyzed the position time graph of drop ball scenario, and based on the terms which I gave you, you would have arrived at a tableau column like this. So we have got time across x-axis, the first column, and velocity across the second column. And you must have found out the instantaneous velocities at point 1, point 2, point 3, point 4, and point 5. And the values which I've got here may not be the same as yours, because there will be some error associated with the way a tangent is drawn by one person and another person. So now what I've done is I've drawn this graph over here to the best scale possible. Yes, this is drawn to scale, but not exactly. There could be some error possible. Right, now we've got velocity across y and time across x-axis. So you can see when I draw a line of best fit for the points which I've plotted, you can clearly see that I get a straight line here passing through the origin. So which means velocity and time are directly proportional to one another, and it also means that the velocity of the dropped ball is increasing uniformly. When I say uniformly, I mean to say that the velocity is changing by the same amount for a given fixed duration of time. Now is there a way to measure this, or rather quantify this? When I say this, I mean, is there a way to quantify or measure how fast the velocity changes? So mathematically, that will be actually, if you think about it, it will be change in velocity divided by time taken. Now this quantity is given a name, and this quantity is what we call as acceleration. But what acceleration? Is it average acceleration or instantaneous acceleration? Now the definition or the word instantaneous still means at an instant in time. So since we are talking of time taken, which means it's talking of over a duration of time, this will be actually average acceleration. So the learning goal was actually to define average acceleration. So average acceleration is defined as change in velocity divided by time taken. Now let's quickly find out the acceleration of this graph. Now if you think about it, the average acceleration would be nothing but the gradient of this graph, and the value comes to be approximately 10.7. Now what is the unit? The unit of velocity is meter per second, and what is the unit of time? It's second. So what is the final answer I'm getting? I get 10.7 meter per second square. Right, now it is time again to understand the meaning of this number. I'll go by this to explain the meaning of this number. What does this mean is that it means in 1 second. It means in 1 second. In 1 second, the velocity of the ball changes by 10.7 meter per second. In this case, it's actually increasing by 10.7 meter per second in 1 second. That is the meaning of this number, or rather that is the meaning behind acceleration. Now if you look at it very closely, this number has got some meaning, guys. Think about it. This number has got a different meaning altogether. Think about it. Thank you.